24. So the only way you can add or subtract radicals is if they're the same. So one of the first things we're going to do is try and get rid of the radical on the bottom, which means times 2 over 2 times 3 over 3. So now I have the square root of 6. And this is square root of 2 times square root of 2, which is 2. Minus 4, on the top we have 6, and on the bottom we have 3. And now the only perfects in here is the 4. So I have 2 square root of 6. So now what we've got here is 3 halves square root of 6, net minus 4 thirds square root of 6, minus 2 square root of 6. So what we need here is a common denominator. You cannot add fractions together that aren't common denominators. Common denominator is going to be 6, so what we're going to do is multiply 3 over 3, 2 over 2, and 6 over 6. So I am multiplying this through. That puts on the bottom a 6. 3 times 3 is 9. 9 square root of 6 minus 6 on the bottom. 4 times 2, this is not under the radical, is 8 square root of 6 minus 12 square root of 6 over 6. Now I can add fractions. So 9 minus 8 is 1. 1 minus 12 is negative. Square root of negative 1 equals I. So what I have here is 2 square root of 2 square root of negative 1 square root of 2 plus 3i square root of 2 minus square root of 2 square root of negative 1 and 2. So what I did was take this from here. So everywhere there is a negative 1, it becomes I. So now I have 2. This is an I. What's square root of 2 times square root of 2? It's 2 plus 3i square root of 2 minus square root of 2 times square root of 2 is 2. This is an I and this is an I. So now, if that's the case, up here, I squared happens to be negative 1. So now I've got 4i plus 3i square root of 2 minus 2 times negative 1. So here's a positive 2. Now we could factor out the I and leave this as 4 plus 3 square root of 2. Now that would work, and if we're looking at standard form, we would write it as 2 plus 4 plus 3 square root of 2i. A plus bi. That's the form that we're looking for. Alright, now we're going to simplify this. The first thing we're going to do before we deal with anything down in the denominator is try to simplify the top first. 2 times negative 1 minus 3i plus 4 all over negative 1 plus 2i minus 1. Now I've got negative 2 plus 4, so that's 2 minus 3i, all over negative 2 plus 2i. Now we're not allowed to have imaginary numbers in the denominator, so now what we're going to do is multiply it by its complex conjugate, which is the same first one, the opposite second one. And now we're going to FOIL this, and we FOIL it, the bottom should have no i's in it. So now on the top I get first, which is negative 4, outer, inner, last, all over. Now the inner and the outer go away, so we're only going to multiply the first, which is 4, and the last, which is minus 4i squared. So on top, this is a negative 1. So now I have negative 4 plus 2i plus 6 times negative 1, and I'm showing more steps than probably are necessary. And so now what I have is negative 6 and negative 4. That's a negative 10 plus 2i all over 4 plus 4, which is 8. Can't leave it that way. There are some things that can be factored out. They're all even, so let's take and factor out the 2. When I do that, I get minus 5 plus I all over 2 times 4. Those cancel, and now what we have is minus 5 over 4 plus 1/4 I, and that is in A plus BI form. Okay, on this example, we're going to follow all the rules of exponents. We have the same bases here, so when we do that, we're going to have the same, with the same base, we add the exponents. So we're going to say y, x plus 3 plus x divided by 2 minus 1, z over a. And if we bring these up, what we're going to do now, well, let's put it this way, x plus 3 plus this one, and then we subtract this one. So let's write that down first. So now I'm going to subtract x minus a over 2 times, and it's z a minus this whole thing, x minus a over 3. Now let's see if there's anything we can simplify. All right, what's 3 minus 1? It's 2. So now what I have is y. I'm going to put the x plus x over 2 minus x over 2. All right, so and then if I distribute this through, it's going to be a plus a over 2, z a minus x over 3 plus a over 3. So now let's see what we can do. It looks like these are going to go away. So now what we have, and I forgot this minus 2, so minus 2. So now what I have is y, and I've got x minus 2 plus... All right, and now let's look here. We have z, 1 1/3, so that's 4/3 a minus x over 3. And we are finished. All right, the best way to simplify this is to put everything in fractional exponents. So what I've got here is x to the 3/4 times x to the 1/2, y to the 1/2 times x to the 1/2 times x to the 4/3. Now there's only one y, so we're going to leave it alone. These are all the same base. So now what I have is 3/4 plus 1/2 plus 1/3 plus 4/3. And so now we have to add all these fractions together. Now you might put them in your calculator and add them, but you also need to know that you're going to have times without a calculator. Alright, so now 3/4 plus 1/2 plus 1/3 plus 4/3. Looks like the common denominator is going to be a 12, which means now I have 9/12 plus 6/12 plus 4/12 plus 16/12. 15 and 4 is 19. 19 and 16 is... Sorry about that, folks, but this got transposed as a half. So that's where this goes, which makes this. So now what I have is 9 plus 6 is 15, 21, 37. So x 37 over 12. Don't forget the 1/2 times y to the 1/2. And now we have simplified it. In calculus, you will almost always leave them in fractions and not in radicals.